Welcome back to the 28th part of Debugging at Scale, where every test we write is a winner. I recently gave a talk about debugging for the London Java Community Group. During the Q&A part of the talk, someone asked me about my approach to test-driven development. In the past, I looked at that practice in a more positive light. Writing lots of tests, how can that be bad? Test-driven development is a process that's a bit confusing to many developers because it has two extreme versions. Weak TDD means writing tests before you write code using short feedback cycles. Strong TDD, on the other hand, uses red-green refactor cycle, where you write a minimal failing tests, write the minimum code possible to pass the test, then refactor everything without introducing new behavior. Fans of TDD define it as a design, not as a test. The design is written in the tests, and the implementation is based on the design within them. As time moved on, I see TDD in a different light. I see it as a very limited tool that has very specific use cases. It doesn't fit into the type of projects I build and often hinders the fluid processes it's supposed to promote. I want to first clarify that every pull request should have good coverage. This isn't TDD, it's just good programming. TDD is more than that. In it, we need to define the constraints and then solve the problem. Is that approach superior to solving the problem and then verifying the constraints are correct? That's the core premise of TDD versus just writing good test coverage. TDD is an interesting approach. It's especially useful when working with loosely typed languages. In those situations, TDD is wonderful as it fills in the role of a strict compiler and linter. There are other cases where it makes sense when we're building a system that has very well-defined input and output. I've run into a lot of these cases when building courses and materials. When working on real-world data, this sometimes happens when we have middleware that processes data and outputs it in a predefined format. The idea is to construct the equation with the hidden variable in the middle, then the coding becomes filling in the equation. It's very convenient in cases like that. Coding becomes filling in the blanks. But there's quite a lot of baggage that comes with TDD. I would argue that testing itself, not TDD, is a bit like double entry bookkeeping. Yes, we should have testing. The question is, should we build our code based on our tests or vice versa? Here, the answer isn't so simple. If we have a pre-existing system with tests, then TDD makes all the sense in the world. But testing a system that wasn't built yet, there are some cases where it makes sense, but not as often as one would think. The big claim for TDD is that it's design. Tests are effectively the system design, and we then implement the design. The problem with this is that we can't debug a design either. In the past, I worked on a project for a major Japanese company. This company had one of the largest, most detailed sets of annex design books. Based on those design specifications, the company built thousands of tests. We were supposed to pass a huge amount of tests with our system. Notice that most weren't even automatic. The tests had bugs. There were many competing implementations, but none of them found the bugs in the tests. Why? They all used the same reference implementation source code. We were the first team to skip that and do a clean room implementation. The test perpetuated these bugs in the code. Some of them were serious performance bugs that affected all previous releases. But the real problem was the slow progress. The company could not move forward quickly. TDD proponents will be quick to comment that TDD project is easier to refactor since the tests give us guarantee that we won't have regressions. But this applies to projects with testing performed after the fact. It gets worse than that. TDD focuses heavily on fast unit testing. It's impractical to run slow integration tests or long-run tests that can run overnight on a TDD system. How do you verify scale and integration into a major system? In an ideal world, everything will just click into place like Legos. I don't live in such a world. Integration tests fail badly. These are the worst failures with the hardest to track bugs. I'd much rather have a failure in the unit tests. That's why I have them. They are easy to fix, but even with perfect coverage, they don't test the interconnect properly. We need integration tests, and they find the most terrible bugs. As a result, TDD overemphasizes the nice-to-have unit tests over the essential integration tests. Yes, you should have both, but I must have the integration tests. Those don't fit as cleanly into the TDD process. In the next video, we will discuss writing debuggable code, starting with the fail-safe versus fail-fast principles. If you have any questions, please use the Slack channel to ask them. Thank you.